Going to be going through 13E today from the Unit 1 and 2 Methods textbook. This exercise is focusing on is logarithmic laws. So we are going to talk about the relationship today about logs and exponents. So we really need to understand if we've got y is equal to a to the power of x. If we're converting it into log, we've got log base a, y is equal to x. So whereas our a is our base, then our y is our answer, our number, and we're trying to find x, our exponent. So we always use our understanding of logs when we are needing to find what the exponent is. So for instance, just the basic questions we can see, we know 2 to the power of 3 is 8, but if I didn't know that my exponent was 3, I could go log base 2, 8, and that will give me 3. So that is where we use the calculator using our understanding of logs. So we've got two laws that we are going to focus on. We've got the product law, where we need to be thinking about with this is when we are adding logs together, we are actually timesing m and n. So it's because it's the opposite of what we were doing with our powers. So with our powers, and this is what this our log base AM gives us. It gives us our power. So normally when we're adding our powers together, we are really timesing M and M together, our, our numbers. Likewise, our quotient rule, same thing. When we are taking away our exponents, we know log base AM gives us our exponent. So if we're taking our exponents, we're actually dividing that number. So we're doing M over N. If I wanted to prove it, I'm just going to make log base AM equals X and log base AN equals Y. We're going to define this relationship in an exponent. So we're going to change it to a to the power of X equals M and a to the power of Y equals N. Now, if I am going to multiply our expressions, we know a to the power of X times the a to the power of y will give us mn. That means we are adding our exponents. So if I go back from this form, we know we've got log base a, mn is equal to x plus y. And our x is log base am, and our y is log base an. Likewise, when we're dividing, I'm just going to make each one equal x and y. I will change them to a exponent again. This time, we are looking at quotients, we are dividing. So we are going a to the power of x divided by a to the power of y, and that's m to the power of n. We simplify it, we're dividing, so we take away our exponents, and then we convert it to log. So we've got log base a mn is equal to our exponent, which is x minus y. Our x and y, if I plug that in, it goes straight back to this rule. Other two we need to be thinking about. We've got law 3, which is the logarithms of a power. And that's where if I've got m to the power of p, that p can just be taken out the front. Likewise, I'm looking at our negatives, but that's the same as our logarithm of power because I'm grabbing this negative and taking it out the front. So let's prove this. So again, I'm just going to say log base a m is x. I'm going to define and change to an exponent relationship. So I've got a to the power of x equals m. If I apply the exponent p to both sides, so I'm doing something identical. Okay, so we can simplify our exponent to be xp. Now, if I apply the understanding of logs, I'll have log base a m to the power of p is equal to xp. Then the final part, is we are going to substitute our x value back in. So if I substitute that back in, what it tells me is when I've got a power of p, I can take it out the front. I'm not going to do the negative one as proof because it's identical. This one here, we know when we've got a to the power of 0 is equals to 1. So when we have got log base a 1, it is going to equal to 0. And log a is equal to 1. So, and this is referring to if I've got 10 over 10. Okay, so without a calculator, let's try and evaluate this. So log base 2 to the power of 64. So the first thing I'm going to do is use the exponent relationship. So I know this will be 2 to the power of what equals 64. 2 times 2 times 2 times 2 is going to need to be 6 lots of 2's. Likewise, when I've got this question here, 10 to the power of what is 0.01, changing it to an exponent. Now, we need to be thinking about if I've got times 10, I'm moving my decimal point to the right. So this time, because I'm wanting it to be to the left, it needs to be -2. Okay, so law 1, we've got log base 3, 5 plus log base 3b. So because we are adding, we are timesing my 5 and b together. Likewise, law 2, we are taking away, the base is the same, so I'm just going 20 divided by 5 equals 4. We know 4, log base 4 is going to give me 1. And if you get confused with that rule, I just want you to think about this. It's got base of 4 to the power of what gives me 4. If it's going to stay the same, it has to be a 1. Okay, let's apply law 3. So law 3, when I've got log base 3x to the power of 4, that 4 goes out the front. That gives me 4 log base 3x. With this one here, I don't like having it as a fraction, so I'm going to change it and I'm going to make it as a negative power. So that will give me 8 to the power of -1. I then want to convert this 8 to be 2. So I can do that, but I'll make it a bit easier first actually, and take the negative all the way out the front. And now I'll simplify this. So 2 to the power of 8 is going to equal 3, so it'll be -3. Another way I could write this, I was going to do it over here. I'll put the answer there first, is negative log 2, and then I can write 8 as 2 to the power of 3. That 3 goes out the front and gives me -3 log base 2, 2. Now we know when we've got 2, 2, it has to give me 1. So it's saying 1 times -3 equals -3. For log base 4, x plus 5, take away log base 4, 2 is equal to 1. So the first thing I'm going to apply is, I know I'm taking away, so I'm dividing. So it'll be x plus 5 over 2. Now I'm going to change it in terms of understanding exponents. So that means I've got base of 4, exponent of 1. So 4 to the power of 1 is equal to x plus 5 over 2. We know 4 to the power of 1 is 4. So we are going to times both sides by 2 to get the fraction gone, and it becomes 8 equals x plus 5. And then I take away 5 and I get x equals 3.